Okay, everybody. So recording, don't say anything you wouldn't say in front of your mom. All right, you want to make her blush and be on recording and then have the whole introverse or the interwebiverse have you recorded saying something, all that good stuff. Okay, really quickly, I'm going to bring up the assignment, and that way you guys can let me know if you have any specific questions. If you already know that you have a specific question about a problem, I'm happy to answer that for you all. Okay, so hopefully you guys can see assignment number 1. All right, let me try again, just in case. It usually has a green box around the screen, but it doesn't. Now it does. Okay, so here's assignment 1. Hopefully you guys can see it. And I'll just take this opportunity to ask if anybody has any specific questions about any of the problems or the formatting or anything of that nature about assignment 1. You can either just shout it out, put it in the chat, whatever you feel is necessary.
I was wondering if we could go over 9A.
9A, I'd be happy to do so. I'll do my best. I don't know if I'm any good at this stuff. So maybe that's why I just give you guys videos all the time, because I really don't know what I'm doing. All right, so 9A. And I'm going to copy this really quickly. All right, so just hang tight. Or I'm going to try to copy it really quickly. Sorry, I have to move back and forth between 2 screens, guys. It's not necessarily all that effective. So we have P implies Q, or I'm sorry, P and Q implies not R. And then we have P or not Q. And what else do we have here? Not Q implies P. And then finally, all that's supposed to be not R. All right. So would have been nice if you guys could give me an easy one to do. I'm kidding. That's why you guys give me the hard ones to do. All right. Here's the way I do this. Okay. And you might have a different way of doing it. It says to do it by truth table, I believe. All right. So let me verify. So it says use a truth table to determine if the argument form is valid. All right. I'm going to start with my columns, my P, Q, and R. All right. So bear with me as I set this up. True, 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 true. False, 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 false. And then true, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false. All right. So that in itself should be worth 20 points, just being able to do that. Okay. It's not. Oh, and by the way, I did see, Braden, I did see you're in the chat. So yeah, I'm happy to go through that as well. Sure. Okay. Here's the way I approach this. All right. I'm going to try to build all of these. Okay. And I'm going to see if the conclusion leads to not R. Any row in which all the premises are true are the critical rows. Okay, so that's what we need to do first, is we need to identify the critical rows. All right, so I'm going to start by maybe just getting P and Q. All right, because that way I can kind of build off the P and Q implies not R. And then I'm also going to need not R anyway. All right, so when I'm doing these, I don't want to do all of this at once, okay, if I don't have to. All right, so we know with P and Q, the only time P and Q is going to be true is in this row and this row. Anytime you have one false, which we do a lot of, all right, then P and Q is going to be false. So this is going to be true, true, and then false, 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 false. All right. Hey, that's good news, because guess what? This is not a critical row. This is not a critical row. Oh, I'm sorry. I can't do that yet. I forgot about the implies R. Sorry, guys. That would have been nice. All right. Still got to do the not R. So not R is just going to be the negation of this column with R in it. Okay. So we're going to have false, true, false, true, false, true, and surprise, false, true. Now, one of the nice things about an implies or a conditional statement is that if you start with a false, okay, because remember, this is what you're doing, you're implying this. If you start with a false, the conclusion has to be true. All right, so all of these are going to be true conclusions, okay, because notice that false, 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 false. There should be 6 of these. Did I miss one? I checked all 6 of them. Okay. Over here, we have true implies false. That is the only time that a conditional statement is going to be false. Okay, so the only time a conditional statement is false, true implies false. And then we have true implies true, which is going to be true. All right, so the only row that we can knock out so far is going to be the first row. All right. Now, the next thing I'm going to do is I'm going to build a not Q column. Okay. And the reason I do that is because I notice I have a not Q here and a not Q here. Okay. So not Q, negation of this. So that's going to be, we don't even care about the first row, but that's going to be false and then true, true, and then false, false, and then true, true. Now we can build the not P or not Q. Or I'm sorry, P or not Q. So P or not Q. All right. So we're going to look at these 2 columns, P or not Q. All right. And remember, for that to be true, you only need one of the true for a disjunction to be valid. Okay. So we already know that the first 3, and I know the first 4, but I'm not counting that one. So I know this one's true, and this one's true. All right. And then since this is false and this is false, then we're going to have a false, false, and false. So this one's going to be false. And then finally, doesn't matter. We get 1 true. So we have 2 true, true here. All right. Once again, that helps us a little bit because now we can get rid of a couple more rows. Okay. Because remember, we're looking for the critical rows. Critical rows are rows in which all the premises are valid. So this is like premises 1, premises 2. All right. So we're getting there. All right. Not Q implies P. All right. Now remember, anytime the antecedent is going to be false, the conclusion is going to be true. So anytime we have a false right here for not Q, the conclusion's true. All right. So now I have to look at not Q implies P. So I'm going to go all the way back here. So I have a true implies true. That's true. Okay. I'm sorry, it's true implies true because it's 3rd row. All right. Then we have 4th row. So we have true implies true. So that's true. The last 2 should be false because I have, and this is, by the way, this is not Q implies P. So I have a true implies false. So that's false. And then I have another true, which implies false. So that's false. Okay. So we know that this is not critical. This is not critical because it's false. These weren't critical. So realistically, to me, there's only 3 critical rows. Okay, this is premise 3. Okay, so row 2, row 3, and row 4 should all be critical rows. Okay, and let me pause here. Okay, because I know I did this on the white screen, and it's honestly really difficult for me to kind of eyeball these up. But I just want to make sure that a few people got the same thing. Okay, so anybody put in the chat. But did anybody get the same thing that rows 2, 3, and 4 were the critical rows for 9A? I'm pretty sure that's correct. Okay, thanks, Michael. I appreciate it, sir. All right. Now, we know what the critical rows, thanks, Newton. Good stuff. Okay. We know what the critical rows are, right, guys? We're looking for the conclusion to be true. Okay, so conclusion must be true. Okay, for the statement form or for the argument form to be valid. So check this out. The conclusion is not R. So this is our conclusion. So in this row, we're good. In row 4, we're good. But right here, we have a false conclusion. Okay, so that one little row is going to make this an invalid argument form. Okay, so the way you guys would answer this, okay, is you would say that note in row 3, or something to the effect of this, the row is critical, but the conclusion is false. Okay, hence our argument form is invalid. All right. So, Yeah, those aren't fun problems, especially with the truth tables. Good thing I didn't give you guys 4 variables, which I never would. Okay. All right. I can't remember who asked me that. I think it was Jackson. But so did that help out to be able to go through and see like where you might have been confused and to resolve that confusion?
Yeah, that did help. I did have one additional question, like just where I got stuck on it. Is there like an order of operations with the logical stuff? Because I couldn't find anything like that.
Gotcha. Okay. Yes. Okay. So order or the precedence, if you would. Okay. Not always has the highest precedence. Okay. So no matter when you do these, the not gets highest precedence. After that, the ands and the ors get the next highest precedence. The least highest precedence is implies. Okay. So that might have been helpful if you didn't see that. Like for this right here, you'd have to do P and Q first, and then you'd also have to do not or before you could finish out what this first one was. Okay, so
Yeah, that's actually where I got confused. I wasn't sure about that exact thing.
gotcha. Okay, yeah. And by the way, so I apologize. I think I might have done the precedence like in one of the videos at one point. So obviously, if you glossed over it, if you didn't see it, then that doesn't help you for this. Okay, so I'm glad that helped out. Okay. All right. Does anybody else have any other questions about 9A before we move on? And I noticed in the chat that there are a number of people asked me about number 11. So that'll be my next objective to work with you guys if there's no more about 9A. Okay. All right, guys. So number 11. To me, numbers 11 and numbers like 5 and 6 are probably the worst ones. The Boolean algebra, as well as these using the rules of inference to be able to validate the argument forms. All right. What I'm going to do is let me copy down number 11A. I had it and it ran away. Oh, here it is. Maybe it didn't run away. Maybe I just don't know what's going on. You guys can write that on the teacher evaluation if you want. Okay. So we have P or Q. Q implies R. P and S implies T. And again, order of operations would mean that you would do P and S first, not R. Q implies U and S. And again, it'd probably be helpful to use the parentheses. All right. And then all that is supposed to lead to T. Okay. All right. So let me go through this with you guys just to make sure that if you're having issues that those can be resolved. Anytime you do these types of problems, start out with the easiest or the most simplistic argument that exists, or the most simplistic premise that exists. In this case, not R is the most simplistic premise, and that's where I'm going to start with this. Okay. And then from there, what I'm going to do is I'm going to look for something else that has an R, which is Q implies R. Okay. Once I have that, then what I'd like to do is I'd like to look at that sheet or that page in the guided notes that has all of the different what's it called? The rules of inference. Okay. And correct me if I'm wrong, guys. There's like 7, 8, 9, 10 of those. Okay. The ones where you have like modus tollens, modus ponens, conjunction, that sort of stuff. So that's where you want to be with this. Okay. For the examinations, I'll have all those for you guys. So I don't expect you guys to memorize all that stuff. You guys can have the sheet that contains the Boolean laws as well as the basic rules of inference. Okay. But anyway, I know that doesn't help you with this problem, but just kind of thinking about it as we go ahead. All right. For step 1, all right, and this is how you guys want to always try to, I guess, try to verify these, is you want to have steps when you're doing this. Step 1, Q implies R. Okay, that's given. Then you have not R, which is also given. Therefore, if you notice that there's one of the rules that says P implies Q, not Q, therefore not P. That's modus tollens, right, guys? So right here, you would say, therefore, we would have to have not Q by modus tollens. All right. again, whenever you guys do these, P doesn't always mean P. P just means like some sort of arbitrary statement. Okay, so kind of be thinking of it in that fashion, guys. P is just representative of the structure that's going along with this. Okay, all right. Now, the way I try to suggest this is I always try to suggest that once you get something from a conclusion, then maybe use that to be able to figure out something that has something else to do with the Q. Okay, and there's actually two different statements that have Q's in them now. Okay, so now we're going to use the not Q. Right here, we have P or Q. So that's given. Well, we just proved not Q to be true from step 1. So you either have P or you have Q. You don't have P, so therefore you're going to have, or I'm sorry, you don't have Q, so therefore you have P, and I believe that's by elimination. Okay, so, and this is actually precisely what it looks like on the sheet. Okay, all right. Now, I also notice that I have this Q implies U and S, all right, and I have not Q. Okay, so how can that help us? Well, we have, did I copy that wrong? Hold on one sec, guys, because that doesn't make a lot of sense. We have not Q implies U and S. So it doesn't help us too much. Oh, it's not Q. Duh. I'm sorry, guys. It was a copy error. I think I circled it and I kind of blended out my not Q. Duh. Okay. Actually, I just didn't even copy it down. Okay. Yeah, I was looking at that and I was like, if that's not a not Q, then there's no way you guys could do this. Okay, but okay. So, all right, getting there. All right, so done with this one, done with this one, done with this one. So for step 3, we're given that not Q implies U and S. Okay, so that's given. We just verified not Q from step 1. Okay, so we have not Q from step 1. Therefore, if the premise or if the antecedent is true, then the conclusion is true by modus ponens. So that's going to be U and S by modus ponens. Okay. All right. I'm going to pause, just make sure everybody's okay and nobody has any specific questions up to this point. Okay, so everybody good, guys? Any questions about these?
So you're going to have to keep track of both conclusions, both the P and U and S, right?
Right. Yeah, because you're going to need these. Nice. Right. Yeah, because ultimately, I mean, we do need P and S, right? And I think that's where you're getting to, right, Michael? You're trying to get to the point where you have P and S to get to T. So nice. Okay.
Yeah.
Before we can do that, though, we have to do one more step before we can kind of conjoin P and S together. Because we have U and S, but we really don't want the U for any reason. The U is just a byproduct. And so what we're going to do is we're going to say, okay, step 4, we have U and S from step 3. Therefore, we're going to have S. All right, we only want one of the two, and the only one we want is S. Correct me if I'm wrong, guys. I believe that's specialization. Okay, I'm doing these all off the top of my head. So, okay, so I think that's the rule of specialization. All right. Now, I want you to notice that as Michael just noticed very nicely, we're trying to keep track of P and we're trying to keep track of S. Well, we got P in step 2, we got S in step 4. So we have P in step 2, we have S in step 4. Well, if I've got P, I've got S, that means I have P and S, okay? And I believe that's conjunction, right, folks? And again, I'm getting all these steps on that basic rules of inference sheet. Okay, Last thing I need to do is I need to go back here and I need to just use this very last rule. Okay, so we've used all of these. So finally for 6, we have P and S implies T. All right, that's given. Right. Well, we got P and S from step 5. Therefore, we have T. That should say step 5 in English, not STO5 or STOS or whatever. Sorry about that. Tough to write on the white screen quite often. All right, so that should say step 5. There we go. I know it doesn't look any better. Oh well. This is by your modus ponens, right? All right. So remember, if you have P implies Q, if you have P, therefore Q. That's the structure that it fits. Okay. And then you're done. It's valid by using all the above steps of summary. Okay. All right. So by the way, guys, like I said, of all the stuff on the assignment, this is one of the most difficult problems. Okay. The way I think of it, guys, it's like a big puzzle. Okay. You have like these rules. You have like sort of like the conclusions that you can draw from the rules of inference, and you just have to use them in the right order. Okay. So my suggestion again is, guys, start with the easiest stuff that you have and go from there. Okay. And then you're probably going to use a lot of like your modus ponens and modus tollens. Okay. So you should be using those quite often. Okay. So start here, use the other thing with an R and go from there, similar to 11B. Okay. I know 2 people asked me about this one. I'm hoping that that helped out, but does anybody have any specific questions about 11A that I didn't resolve or that you still had questions about, or the process in general with this? All right, guys. What other questions can I help you all out with on the assignment? Not in physics. I'm not doing your physics homework for you. Sorry. Could we also do B? I'll tell you what, Mike, do you mind if I start it for you guys? Because I do want to make sure that you guys are at least getting some practice with this. Okay. But yeah, I don't mind doing like the first 2 or 3 steps and then letting you guys finish it out. Okay. All right. So 11B. All right. And if you guys are truly still stuck on it, what you guys can do is you could just shoot me an email and you can show me where you are and take a picture of it, and I could try to help you out by that. Okay. But I do want to make sure that you guys are getting at least some practice. But yeah, I don't mind helping out with a little bit with this. All right. So not S and not U implies V. Q or not T. All right. And by the way, as I'm writing these, if I make a copy error, somebody please just yell at me and let me know. All right. P implies Q. That's nice. Not P, not Q, not T. Implies S or implies not S. Not Q, not U. And therefore V. All right. All right, folks. Start with the easiest part. And there's actually 2, I'm going to put quote unquote easiest parts to start with. Okay. I'm going to start this one with not Q. All right. Just because I can use the not Q to be able to help me with this premise and this premise, right, guys? Because I can use those to be able to get some sort of conclusion. All right. I'm going to do the modus ponens first, or the modus tollens first. Okay, so step 1, what you guys are going to do is you're going to have your P implies Q, okay, as given. And then you're going to have not Q, which is also given. And that's going to give you not P by modus tollens. All right. You're going to hold on to not P. All right. And I think Michael gave me this suggestion earlier, is because you need not P later, right, to be able to get to not S. All right. So just keep thinking about that, guys. When you look at these, see where that's going to be helpful for you. Okay. It doesn't immediately help you with any of the premises that are given, but at least it helps you later in what we're doing. Okay. Now, I've already used P implies Q, done. I'm going to use not Q again right here. Okay, so I have Q, N, or not T, excuse me. I have not Q. All right, so these are given, or this is given, and this is given. And so therefore, since I don't have the Q, I'm not Q. Instead, that's going to leave me with not T. All right, and that's given as well. Or I'm sorry, that's going to be by elimination. All right. Now, I want you guys to notice we need the not T, right? We need the not P because we need a not P here, a not Q, and a not T. We just got all of those. Okay, we already have not Q, which is given. We have not P from step 1. We have not T from step 2. And so my next step for this would be not P from step 1, not Q, which is given, not T, well, almost not T. It's like upside down partial sort of character there. And then and that's from step 2. So therefore, that's going to give me all 3 of those. I've proved all of them. Okay, I've proved that not P is valid. I already had not Q. It was an assumption. I proved that not T was valid. So that's going to give me not P and not Q and not T. And that's by our conjunction. Okay. Now to finish this, guys, okay, so you've obviously used the not Q up. Okay, we've already used not Q and T. What you guys are going to do, step 4, okay, you're probably going to use this animal right here. Okay, and you're going to get yourself a modus ponens out of that. Okay. Then from there, you can almost finish it off because you're going to have the not S and the not U. Okay, so you're probably going to have another conjunction. And then at the very end, to get V, you're probably going to have another one of the modus ponens. Okay, so I'm going to let you guys finish that out. And I see the question. I'm sorry, Braden. I didn't realize that you asked a question here. Question: can you reuse conclusions or the given arguments? I realize that you are reusing not Q. Okay. The answer to that question is yes. Okay, because it's already been proven true. As long as you prove something is valid, you can keep reusing it as many times until for some reason you prove it's not valid. Okay. So, and in fact, in this problem, you absolutely have to do that. Okay. There's no way to be able to do this problem without reusing the not Q. Okay. So, and that might have been where some of you guys got hung up with. Okay. I know the ones in the videos, I might have only used the premise once and then I crossed it out. Okay. And most times that's the way it works. Okay. Not every time. Okay. All right. So, Michael, did you need any more help? Do you feel like you're on a good trajectory to be able to complete this one now? Just want to make sure I'm not leaving you completely hanging. Okay, that helps a lot. Good. Okay. All right, guys. Any other questions? Oh, for step 3, I actually broke it into 2 steps. Yes. Okay. Yeah, absolutely. Because another way you could do this, okay, and that's great, Jackson. Nice. Another way you guys could do step 3 is you could do not P, not Q, therefore not P and not Q, and that could be step 3. And subsequently, you could have not P and not Q, not T, therefore not P, not Q, not T. And then these would become steps 5, 6, and 7. Although if you wanted to just do it in all one step like I did, that's fine too. Okay. So yeah, either way works. Okay. Thanks for noting that, Jackson. I forgot to mention, just in case some people wanted to break that conjunction up into 2 steps, certainly they may do so. Okay. All right, folks. Any other questions I can answer about number 11B before we move on? Or problem 11B? Okay. All right, folks. What else we got about assignment number 1? Any other questions, problems, concerns? Number 6 was the other one giving issues. Okay. Yeah, traditionally, number 6, pain in the ass. Okay, so let me go through. I'll try to work that one for you guys. And once I copy it down again. All right, so give me a sec, folks, or maybe 3 seconds. Yeah. All right, so number 6 asks us to verify by Boolean algebra. All right, so that's where we have to use all those logical rules of inference. So we have P and not P, or Q, and we have 3 parentheses there. All right, yeah, I'm like staring at it. Or P and Q. And all of that is supposed to be equal to P. All right, so imagine trying to use a truth table in this thing. All right, it'd probably be pretty ugly and also pretty unwieldy to use this. All right, whenever you're doing the Boolean algebra stuff, okay, keeping in mind that not has the highest precedence, my suggestion would guys would be if you can use a double negative or De Morgan's law, do it. And clearly inside the parentheses right here, you have a De Morgan's law. Okay, so I'm going to use De Morgan's law on this. And I'm going to end up with P and not P, right? When you use De Morgan's law, that flips the quantifier. We have a not Q. And the other stuff is going to stay exactly the same, or P and Q. And that's supposed to be equal to P. When you do these, make sure that you give me some inkling. I know I can't spell it. Sorry, guys. You give me some inkling of the law that you use or the rule. Okay, so this is De Morgan's law. All right. Next thing I'm going to do, and by the way, you could do this in one step if you wanted to do De Morgan's and double negative, no problem. Okay, I'm just going to use 2 steps because that's technically the right way you're supposed to do it, but you know, whatever. I mean, most people in algebra, you don't, you know, if you have a double negative, you don't put negative and then do it. You just go ahead and simplify it. Okay, so this is our double negative. Now, this is the trickiest part, is that noticing that you have 2 ands that are right next to each other. If you have 2 ands that are right next to each other, that's an associative property, and you can move the parentheses around. Okay, so now if you have an and and an or, you can't do that. That's where you have to use the distributive property. All right, but this can be written as P and P and not Q, or P and Q. Okay, so that's our associative property. All right, P and P. All right, well, it's pretty obvious if you have P and you have P, you're going to have P. All right, so this is just going to turn into P and not Q, or P and Q. All right, correct me if I'm wrong, if somebody can verify this one, because I try to memorize them all. I don't always remember them. I believe the name of this one's the idempotent law. It's not the identity. It would kind of make sense identity, but I'm pretty sure it's idempotent. Okay. And again, by the way, if I'm wrong, if somebody's looking at that list and they tell me that it's not idempotent, please either put it in the chat or just like, you know, shout it out that I think it's, you know, I think it's the identity law, even though I'm pretty sure it's idempotent. All right. Other tricky part of this problem is being able to go backwards from the distributive property. All right. And that's actually a technique that you guys are going to have to get good at with this Boolean algebra. I want you to notice that this fits the form P and Q or P and R, because notice you have a not Q and a Q. Those are 2 different statements. Okay. So that fits the form of the distributive property. And what you guys are going to do is you're going to factor this out. Okay, so that's the way I think about it. I know it's not the right way to kind of state it. Okay, but if it helps you guys to notice you have a Pn and a Pn, that's almost like a greatest common factor if you're doing factor by grouping. Okay, I'm just trying to relate it to stuff that you guys know. Right. So what I'm going to do is I'm going to write this as P and what am I left with? I'm left with Q, or I'm sorry, not Q or Q. Okay, and that's supposed to be equal to P. That's our distributive property. Okay, that's probably the toughest one for students to get. Okay, now we have not Q or Q. Okay, well, if I don't have a dollar or I have a dollar, well, that statement's true. Okay, no matter what. Okay, so this is going to be P and tautology. I'm going to use a capital T. All right, if you guys use a lowercase t, that's fine. Okay, I think that's might have been what was on the sheet, is equal to P. All right, not Q or Q. All right, is that one going to be the negation property to get to this guy, or is that the okay, negation? Thanks, Jackson, appreciate that. Your Calc 1 teacher would be happy about that. So negation. All right, and then finally, this is where you guys could use the identity property to finish this one off. Okay, so identity says that you have P and tautology. That's going to be P, which is equal to P, and that's the identity property. All right, somewhere in there it says the word identity. Maybe if you started drinking already today, it says identity. There we go. Although maybe after class, it might make you want to start drinking. So, or if you had physics this morning, regardless. All right. So, yeah, that's a tough one, guys. All right. Michael, did that help out a little bit with being able to see the different processes necessary to get to the conclusion for this? Cool. All right. And by the way, any other questions anybody has about number 6 that I can answer for anybody? Yeah, typically on the assignment. Oh, go ahead. I'm sorry. Michael, for whatever reason, I didn't include a not when writing down the problem. Yeah. Oh boy. True story. When I was in partial differential equations, I copied down a U as like a T or something like that. And I spent 5 hours on the problem and I didn't realize it was the beginning. So yeah, one of the things, and honestly, guys, I've been doing math for like, teaching it for 18 years. Really, if you get stuck with a problem, one of the things you guys should do is go back to the beginning and make sure you copied it down right. Okay, especially with stuff like this, like with integrals. You guys know, like integrals, sometimes if you copy it down wrong, it doesn't have an evaluation. Okay, so for any of you guys suffering through Calc 2 right now, copy down your questions correctly, or if it looks like it's getting out of control, go back to the beginning and make sure you copy it down. Yeah. But yeah, Michael, if I had $1, this is one of those things that if I had $1 for, then I wouldn't be teaching anymore. I'd probably still be teaching, but I wouldn't be teaching as many classes. So. All right, friends, other questions about number 6 or other questions in general about assignment number 1? All right. Okay, guys, so just kind of giving you an overview. Oh, and one thing I wanted to do, I just want to make sure everybody knew where to submit the assignments. So really quickly, let me go back just to make sure. Okay, not trying to belabor this, but I know for a lot of you guys, it's the first time you've taken a class with me. So I just want to make sure that everybody's cool with knowing where to submit stuff. Okay, so what you guys are going to do, you're going to go into Blackboard, the usual. You're going to go to Math 210. Let me move this screen over. All right. And then what you guys are going to do is you're going to click on the assignments link. And then right here, in fact, let me go to the student preview so that way you guys can see what you're going to see. All right. So you guys go to assignments and then you click right here where it says assignment number 1. All right. And I know a lot of you guys have done this before, but I don't want to make any assumptions. Once you do that, just go ahead, browse your local files. Again, make sure it's a PDF file, please. Okay, and then just upload it right here. So you just browse it, and then it'll take you to your screen. and then you upload it. Okay, so here's just a generic PDF file. I'm not going to upload that because blah, blah, blah. Okay. All right. Any questions about how or where to submit the assignments? Just want to verify that. I know I went through it last week, but I don't even remember what I had to eat today. So, okay. All right, friends. Really quickly, just an overview about what's going to go on for this week. All right, just so that way you guys have a heads up. So let me go back to the whiteboard, maybe, possibly, potentially, if I can find it. All right. By the way, I got like 6 screens open. Oh. By the time I get to it, the class would be over. Let me see. All right. Well, let me see if I can stop share. And then let me see if I can share again. It just ran away from me. I don't know where it went. There it is. Maybe. No. Oh, there it is. Okay. Okay, guys. So just a reminder, assignment 1, 5 p.m. today. Okay. This week, what you guys are going to do after you complete the assignment, you're going to look at all the videos from section 2. Okay. So section 2 is usually one of the easiest sections in the course. Okay. Because a lot of people are computer science majors, but even if you're not, it's not meant to be a difficult section. Okay. So stuff you guys are going to be looking at in this section. You're going to be looking at logic circuits. Okay, so for those of you folks that are my computer science majors, you might have seen this in your assembly programming class. You might not. I don't know. Okay. Along with logic circuits, you're going to look at how Boolean statements relate to those. Okay, so the stuff that we looked at before in section 1, we're going to see how that ties in. And then we're also going to take a look at input-output tables. Okay, so in-out tables. Okay. Another thing you're going to be looking at, guys, this week is you're going to be looking at the different number bases. Okay, and you guys know, for the most part, if you're a computer science major, there's 3 number bases you better be really good at. You better be good at binary. You better be good at hex. And if you're in this math class, you better be good at decimal, which is base 10, the stuff you guys have been doing all your lives. Okay. And typical question I'm going to ask you guys to do, convert back and forth. Okay. So I might ask you to go from binary to hexadecimal, from hex to decimal and binary, etc. Okay. The last topic that you're going to be looking at in section 2, you're going to be looking at 8-bit addition. Okay. So in other words, what does a computer have to do to add 2 numbers together? It's going to look at that process. And really, when it comes down to it, guys, it comes down to literally 2 operations, ones, zeros, okay? Push, pop, that sort of stuff. So for those of you guys that are my computer science majors, you understand. If you're a math major, certainly you can see the application of this. And if you're an engineer, well, you're just taking the class to get credit, basically. So, all right. All that stuff is going to be the topics that are on assignment 2. And assignment 2 is going to be due 5 p.m. on February, what's today, the 8th, so that'll be the 15th, okay? And like I said, usually section 2 or the material in section 2 is usually some of the easier stuff in the course, okay? So now, that's not saying that if you guys don't have any questions, not to ask me questions. All right, so everybody cool with what's going to go on for this week? Everybody understand? Any questions? And let me check the chat really quickly because I hid the chat. Okay. All right, folks, I'm going to stop recording really quickly. So 1 sec, I'll stop recording.